Hello, my friends. How are y'all doing today? I hope you're doing well. Got to get that camera adjusted. All right. Let me walk around this room for a minute. Y'all hear me over there? I know I'm still here. If I don't walk around the room, the light's going to turn off on me. Hey, I'm back. I'm excited. Can you tell? Okay, here I am. We're talking about similar triangles today. Similar triangles. So, what do you mean by similar triangles? Similar, the word similar means kind of alike, but not exactly alike. Okay, so let me give you an example. Let's say this triangle right here, I could say that it's similar to this triangle right here. So essentially what I'm talking about when I put these two triangles up here with similar triangles, they are same, similar, same shape, but different sized. Of course, this triangle right here is the same shape as this triangle right here, but this one's smaller. We have a smaller and a larger. Now, what makes the shape the same is actually the angles will correspond. Okay, so this angle right here would measure equal to this angle. This angle over here would measure equal to this angle, and this angle would measure equal to that angle. Okay, but they are the same shape because they have the same angle measures, but they're different sizes. That makes them similar triangles. Same shape, different size. Now, similar triangles. A little tidbit of important information about similar triangles. Similar triangles are what we would call proportional to one another. Proportional. We can use similar triangles to create proportions. They're proportional to one another. For example, if I told you this larger triangle was twice as big as this smaller triangle, twice as big, and I came here and I said, hey, you know what? This left side right here on this larger triangle is 10 inches. And I said, this one is 5 inches. Twice as big. Larger triangle, twice as big. Well, what that means is every side on this triangle, every side, not just one of the sides, but every side will be twice as big as its corresponding side on the smaller triangle. So if I came here and I said that this was 14 inches, what would you guess this to be? I hope you said 7. That would be 7 inches because that's twice as big. But now if I came here and I said that this bottom piece was 8 inches, and since the larger triangle is twice as big, it must be 16 inches. So what you see in these two triangles is we have a 2-to-1 ratio. A 2-to-1 ratio. In other words, the larger triangle is twice as big as the smaller triangle. This is the ratio of the larger triangle to the smaller triangle. It's going to be that way in every single measure on the triangle. Now, from that, we can obviously make predictions about the length of the side of the of missing sides on the triangles. All right, so there we go. That's what we mean by similar triangles. They're proportional, so we can create a ratio. Okay, so let's take a look at an example on how to work with similar triangles. Okay, so we'll say given the triangles below are similar. I'm going to go ahead and tell you up front, they may not look beautiful when I draw them, okay? But I'm telling you, they're similar. I mean for them to be the same shape. That's what I'm going after here. So I'm going to draw a couple of triangles. We'll draw one that's a little larger. Come over here and maybe draw one that's the same shape essentially, but a little smaller, sort of the same shape. And maybe I need to make that a tad bit taller. Kill that. Come down here. Okay. All right, so here's what we're going to do. Suppose I tell you that the left side on this triangle over here is 9 yards. And I come over here and I say the left side on this, the corresponding left side, it's important to understand this is the corresponding side. This corresponding side right here, let's make this, I don't know, let's make this 1.8 yards. Okay? Now, from that information, we can establish a ratio. We have a ratio of 9 to 1.8. Okay? Or we could say 9 over 1.8. 9 over 1.8. That's the ratio that we have here that we're working from with these similar triangles. Now, from that, if I give you another corresponding side, let's say I give you this side right here, and I'm going to make it 13 yards. And I ask you, okay, well, what's the length of this side right here? I can use my information, 9 over 1.8, to create a proportion by simply doing 9 to 1.8, and so right here equals 13 to question mark, or 9 over 1.8 equals 13 over question mark. And so what we've done is we've used our ratio of 9 to 1.8 to create a proportion, 9 over 1.8, corresponding sides. We're going from larger triangle to smaller triangle, larger on top, smaller on bottom, larger on top, smaller on bottom, and we've created a proportion. Now, we know how to solve proportions. To solve that proportion, we're simply going to do 1.8 times 13 divided by 9. So let's do that. I'm going to pull up one of my favorite devices, this handy dandy calculator. 1.8, I'm going times 13 equals, and then I'm going to go straight to divided by 9 to get an answer of 2.6. So question mark here equals 2.6 yards. Now let's just see if that makes sense. If I put in 2.6 right here, let's see if this kind of makes sense to us. This side right here, 13, is a little bit bigger than this side right here, 9. So I'm going to expect the corresponding side over here. Ooh, that's an ugly 2.6. Let me see if I can draw that a little bit better. I'm expecting this corresponding side right here. Still see me? See me now? Okay, good. All right, so I'm expecting this 2.6 corresponding side to be a little bit larger than this side right here. All right, kind of making sense a little bit. Let's carry it on out with a little more information. Let's this time let's go ahead and say that this corresponding bottom side to that bottom side over there. Let's make this bottom side right here. I don't know. What should we make that? I'm going to guess that's a little shorter than either one of those. So I'm going to call that 1.2 yards. Okay? And so now I'm going to put my question mark here. And I wonder what that side is. So here's what we're going to do to find out. It's not a big deal. We can find out very easily. We can say 9 is to 1.8. So we'll just go straight into 9 over 1.8. Okay, 9 is to 1.8. Larger triangle to smaller triangle. Larger on top, smaller on bottom. And set a proportion. Question mark is to 1.2. Question mark is to 1.2. So notice the pattern that we set up. We set up the larger corresponding side over the smaller corresponding side, and then on the other side of the proportion, we set up the larger triangle's corresponding bottom, okay, on top to the smaller triangle's corresponding bottom. If we get this set up correctly, if we get our proportions set correctly, it's very simple to find the length of the missing side, of course. What we're going to do is 9 times 1.2 equals, and I get that, All right, and then I'm going to divide that answer by 1.8. And so we get a magic number of 6. So here, this will be 6 yards. 6 yards. So, guys, this is how we use similar triangle information to end up with finding the lengths of missing sides. Please don't confuse this with Pythagorean theorem. Totally different concept than Pythagorean theorem that we talked about in one of our other videos. But here we're into similar triangles and using the proportionality of similar triangles to come up with the length of a missing side. I hope that's helpful to you as you jump into your homework in 8.8. I believe that wraps up Chapter 8. Cool. All right, so we are looking forward to getting back together. Next time I see you, I don't know, what will we talk about? Maybe we'll talk about statistics. See ya.